All right, can everybody hear me okay? All right, thank you for the introduction, Jennifer, and I'm really grateful to be here. As Jennifer said, I'm Dr. Kody Powell. I'm an associate professor in chemical engineering and also an EGI affiliate faculty. My colleague, Julie Sieving, has contributed to these works. She's not able to be here today, so I'll be presenting on our behalf. I'm going to be speaking about advanced energy projects with EGI, and specifically talking about some of the research that my group is doing. Okay, so if you watch the news, especially energy news, you know that the energy landscape is changing really, really fast. We have cities, municipalities, states, and even our country committing to do things like being 100% renewable, targeting industrial decarbonization, electrification, investing in low carbon fuels and carbon capture, utilization, and storage. Just these very aggressive measures designed to help improve the environment, and that's all great. This might be moving a little bit too fast. If you've seen the headlines in the last couple of years, there are some grid reliability issues that are being introduced. So things like rolling blackouts are happening. These are headlines from last year, but there were predictions of blackouts on the grid. So just things that might be sort of unintended consequences of this revolution to be completely renewable and to decarbonize. So this last quote is from the FERC chair, that's the Federal Energy Regulatory Commission, saying the old way doesn't work. So we need to find new ways to make all of this work. We certainly champion being sustainable and being environmentally friendly, but there are some real problems there. So just fundamentally speaking, what's causing this? So I'm showing here on the left, this is real solar radiation data collected. This is from the state of Texas. This is on a rooftop, and it probably comes as no surprise to anyone that solar energy is inherently intermittent or variable. So we certainly know that the sun isn't shining at night, but even during the daytime, you can get solar energy as the sun goes behind clouds. You can get energy that is not dispatchable or not available on demand. So if we look at the other side of the equation, the demand side, there's actually a surprising amount of variability on the demand side as well. So this is also data from the state of Texas. And you can notice the very different scales here. Where on the left, we're talking about watts per square meter. And on the right, we're talking about gigawatts. But the idea is still the same. There is quite a bit of variability and fluctuation, both in the way that we supply energy, if it's coming from renewable source like solar, or the way that we consume energy. So you notice in the graph on the left with that scale of gigawatts, on this particular day, the Texas grid is going from about 37 gigawatts all the way up to nearly 67 gigawatts. So very nearly doubling over the course of about 12 hours. So how do we manage this? Historically speaking, when we need more energy, we build more power plants, and those power plants have been fossil fuel power plants. The benefit of fossil fuels is that they are available on demand. They're dispatchable, we call that. So we need more power plants, we need more power, we build more power plants, and then we can meet this variable load by operating these plants in this flexible way. That's not as possible with renewable energy. So how do some kind of questions, this big drive for change, how does that impact you in your business? So certainly being more energy efficient is something that is hopefully on your radar. You can save hundreds of thousands of dollars a year, maybe even millions of dollars a year by improving the energy efficiency of your processes. You've probably heard this term ESG. It's a little bit of a hot button topic, but I think we all agree that being environmentally responsible and being socially responsible are important for any business. Whether that gets worked into mandates by the SEC or not is a different topic. So this idea of environment and social governance should be important to everyone in their business. We want to be good stewards of our environment. Getting renewable energy integrated is a topic that's on a lot of people's minds. How do we do this while keeping our processes reliable? The nice thing about EGI has this big focus on geothermal energy with the humongous Forge project. We also have expertise in solar and in conventional power generation and energy storage. EGI brings a lot of nice resources to the table. There's this is kind of a buzzword, but decarbonization is a term that's catching on pretty quickly. How do we decarbonize our processes? And so each of these things that I've mentioned before, efficiency, ESG, renewable energies, those are all steps that you can take to help decarbonize your processes. But if I'm speaking to industrial professionals, probably very concerned about your bottom line. Every business to remain viable, you certainly have to be making decisions that won't adversely impact your revenue streams. So this is a service that we at EGI can help with. We can help you to identify projects. So I run a Department of Energy Industrial Assessment Center, which I will talk about here momentarily, where we can come into your facility. We can do a comprehensive energy assessment of your facility, and we can identify those projects, listen to your needs, and help you know, at least at a high level, how would doing X, Y, and Z project impact your environmental impact and also your bottom line from a financial point of view. EGI can also help with targeted in-depth simulation and analysis. So if there is a particular project on your mind, we have a good number of simulation capabilities and analytical capabilities to really dive in and help you better understand how would a particular project impact the way you're operating. EGI also welcomes partnering with you on large federally funded programs. So if there's a lot of federal dollars out there, which I'll talk about a little bit later, but EGI has many grant writing specialists, and we can help team up with you to do these big high impact projects at your site and leverage money that's available from the federal government. Okay, so first I want to talk about our energy assessment services. So, So EGI is home to a Department of Energy Industrial Assessment Center. And in this program, we send teams of trained professionals and students out into industry. We're also doing commercial buildings. So we can go and survey your facility. We can try and identify the things that you can do to save money and energy. Historically, this program, it's been around for nearly 50 years. It actually predates the formal formation of the Department of Energy itself. So our team can go survey your facility, and we can point out all the different things that you can do to improve the economics of your facility, to reduce energy usage, to reduce and better understand your environmental impact, all kinds of things. We can come and help you identify those projects through this high-level scoping survey. So this program, there are 37 of these centers around the country. If you happen to be joining us from outside of Utah and you'd be interested in partnering with one of these, I suggest you just reach out to your local industrial assessment center, because this is a really value-added service. It's no cost. It's covered by the Department of Energy. So what's really cool about this program for me as a researcher is going out and seeing all of these industrial facilities gives us tremendous insight for how well are new technologies being adopted, or how seriously are companies taking decarbonization, or are they mostly just focused on their own revenue streams? Any of those are perfectly fine. But it gives us this great insight to the point that I actually think this Industrial Assessment Centers program can be a major agent of change in all of these goals that our federal government has. So my research, one of the topics that I get into is what I call grid responsive smart manufacturing. I showed before that graph with the supply and demand, and there's intermittency in terms of supply and fluctuation in terms of demand. So you might think that a natural way to bridge that gap is large scale storage, and that is probably very true. But we actually think that there's quite a lot of flexibility that's already out there in these industrial facilities. So I'm going to show this little video animation this is our vision for how the grid could actually operate. So we know that there's fluctuating supply. The sun is going to be going up and down or going behind clouds. We mentioned there's also going to be fluctuating demand. So one resource that grid operators can use is something called real-time demand response, where if energy becomes scarce, the grid can dispatch signals to encourage facilities to use less energy at that moment to better help support the grid. So this is a concept that is highly underutilized in the manufacturing sector. So here we've shown that when energy becomes scarce, companies can turn equipment down. Then when energy becomes abundant, let's say it's 4 o'clock in the afternoon, there's just an abundance of solar energy. Some of these facilities can do things like change the speed at which they're producing things. They can do things like run pumps during off-peak hours so that they're filling up storage tanks. So you'll see this tank start to fill up. So there's an abundance of energy. This tank starts to fill up. It means you're running your processes extra hard at that moment so that when energy becomes more scarce, you can turn those processes down. So our hypothesis here is that there's actually quite a lot of flexibility potential out there. And by investing more in this concept of grid responsive smart manufacturing, that we can actually make a market impact on the grid. However, this can actually be quite economically beneficial to individual companies currently. So I'll show you how this works. So in our area, and I think this is pretty ubiquitous nationwide, there is this concept of peak demand charges for a facility. So this is the utilities way of trying to keep everybody from overdoing it and overwhelming their transmission and distribution lines. So what they do is they build into the pricing structure these peak demand charges, which basically are a penalty in your bill based on the peak demand. So right here, what we found that in a lot of facilities, it's not uncommon for about 50% of your energy costs to be just based on peak demand. So this can be a single 15-minute period in the entire month. So if in any 15-minute period you exceed this peak demand, that means you're paying extra for energy just from that one instance, basically. So what you can do is you can try to flatten this curve by doing things in a smarter way. Like I showed before, you can try and run your processes extra, store up product or feed in inventory so that later on, when you become demand constrained, you can turn your processes down. So here's how that might look if you're able to shift your energy usage with smart automation. So you could run your process a little bit extra hard here, depending on the flexibility that you have built into your process. And that results in this reduced peak demand. And because about 50% of your energy costs are going to be based on this peak demand, reducing that demand during peak hours can have dramatic impacts on your bill. So I'm going to get a little more concrete here in a moment. This is a facility that the Industrial Assessment Center that we run visited. This has been a couple of years ago now. So this is a mineral processing facility. This particular facility, they run this ore processing. They need water for that, but simultaneously they actually, because it's also a mine, they have to do what's called dewatering the mine. So they have to drop the water table of the mine, which they do via wells. So they pump that water out of the mine, store that in these large storage tanks. So this particular facility already has about 6.2 million gallons of water storage built into it. Then they use that stored water to feed their process. This particular facility, their initial interest was in building a large-scale solar farm to help them with their own corporate ESG initiative. So that was an analysis that we did for them. So our initial analysis of this solar looked something like this, where the blue line represents this facility's real-time power demand over the course of a week. If they added a 6 megawatt solar farm to their operations, this is how that impacts their energy usage. This is the dashed yellow line here. So I won't ask anyone to speak out, but just look at this graph and think about, how does adding solar impact this company's peak? And I'll just give you a moment. So the answer is, it doesn't impact their peak. So that peak occurs right about here. And just by kind of bad luck of the draw, the time that this particular facility is using the most energy does not happen to be the time when the sun is shining and hitting their solar panels. And this may or may not be the case depending on your facility. So if your facility has a diurnal cycle or a distinct night and day cycle on when you're using energy, assuming that you're using more energy during the day, you'd probably get a better peak coincidence here from solar, but this particular facility didn't see any of the benefit. This particular facility also had a really high demand charge. So they were paying about $21 per kilowatt for demand. So at whatever 15-minute period in the month was their highest, figure out how many kilowatts they're using there, multiply that by $21, and that sets the demand charge for this facility. Simultaneously, this facility also had a really, really low energy charge. So if you look at your electricity bill, you probably pay about 10 or 11 cents per kilowatt hour for your home. This facility only paid about 2.3 cents per kilowatt hour. But because industrial facilities have this unique pricing structure, again, their peak demand makes up a significant portion of their bill. I believe for this facility, it was actually over 60% of their utility bills were coming from this demand charge. So the natural solution here would be to couple this solar power installation with the installation of a large-scale battery. And that's well within the wheelhouse of what our center can do for the analysis. So we modeled a solar PV system. We also modeled the battery system, and we spoke with vendors about how much it would cost to install these kind of things. So our analysis showed that it was about $3.6 million additional to install a battery system to help this facility better align their supply and demand. We took a more critical look at this particular process, however, and we came to the realization that this facility already has storage built into it. So they're running these pumps. All of their pumps are equipped with variable frequency drives, giving them the ability to flexibly ramp up and down those pumps. They have this tremendous amount of storage volume here, which currently they just basically run the pumps as hard as they can, and then they keep the storage tanks as full as they can all the time. So, and then when we visited the facility, they were also dumping some excess water into a nearby stream because their dewatering needs were more than their process needed at the moment. So what we looked at is we said, well, you already have this tremendous amount of flexibility built into your system. You can ramp these pumps up or down, and you can use this storage to act as a buffer between these periods of low demand and high demand. So what we recommended is that they develop a smart automation scheme to help them make sure that they have enough water stored in these tanks so they can always feed their process, but to try and fill up the tank during off-peak hours so that they can use it during on-peak hours. So because the pump and water tank system is somewhat disconnected from their actual process, as long as they're managing that in a robust way and making sure that they are extra careful, using things like stochastic optimization, being extra careful that you're not putting yourself in a dangerous spot where you might run out of this water storage to the point that it impacts your process negatively, we felt like there is a pretty high margin of safety for this company to do this. So the nice thing about the storage tanks, unlike the battery system, is that they cost $0 additional dollars. They already exist as part of the process. So if this particular facility used these storage tanks in the way that we recommended, they could do something like drain the tank when you're expected to be above your peak load. So now we're looking again at these two scenarios. So scenario 1 is what they would normally do. Scenario 5 here is what they would do if they were drawing down the tank during those peak hours. So here you're drawing down the tank, reducing your peak demand. And then here you notice that the scenario 5 actually exceeds scenario 1. So here is where you're making up the difference. You're running the pumps a little bit extra hard here to fill up your tank to make sure that you're ready for the next process need. So meanwhile, this is what's happening to your storage volume. So they're going from being totally full, and then as they ride out this peak demand event, they are draining the tank, but still down to a level where there's still a significant storage volume. We had a safety buffer of 1 million gallons, so you never drain the tanks below 1 million gallons in this scenario. So this has a substantial reduction in their peak, and this is manifest in their bill. So we're actually going to show here how all these different scenarios impact their bills. So business as usual, this particular facility, their average peak monthly demand is about 36 megawatts. if they made this 6 megawatt solar installation on certain months, the solar is peak coincident. And so they do see this marginal drop in their peak demand, but the vast majority of the savings from solar come from offsetting that 2.3 cents per kilowatt hour rate. The solar project would cost them about $7.6 million and result in savings of about $270,000 a year. So a simple payback has that at about a 20-year or 28-year payback. So if you're thinking about this from your business with your business hat on, you're probably thinking this is a horrible investment, and I would have to agree with you that solar by itself, just in terms of an economic payback, doesn't really do it. And in fact, you'd probably have to replace the entire solar field before you ever recouped your investment. So scenario 2 is if they just installed a battery without the solar field at all. So here they do dramatically reduce their peak by over a megawatt. The battery would cost about $3.6 million. And if you operated it in an intelligent way, that would save you about $318,000 a year. And that gives you an 11.5-year payback. And that also might be an investment that you'd have to do some more digging into, because the battery may not last that long, depending on how many times you have to cycle it over its lifetime. So we looked at other scenarios like solar with a battery system that results in about a 17-year payback. This smart pumping concept can dramatically reduce their peak, so by about 1.5 megawatts on average. This is really just an investment in sensors and hardware and software. You don't need to make a huge capital investment like a battery system, or even have to build new storage tanks. They are already there. They're built into your process. So this smart pumping scheme results in a savings of about $372,000 a year, which is a remarkably fast payback. This is a really good investment. And really, you're actually doing an environmentally very good thing here, because you're becoming more flexible for the grid, allowing the grid to put more solar and wind maybe in other places that make a little bit more economic and environmental sense. This final scenario we looked at with solar with smart pumping, and that has the best yearly savings, but that still requires the big capital investment in solar, and that results in about a 10.5-year payback. So depending on this company's particular goals, they can choose to just go for the fast payoff, or they can choose to do something a little bit more environmentally friendly and contribute renewables to the grid. I will say the particular location, which I don't want to disclose, was not a particularly great site for solar. So I think it makes more sense, globally speaking, for them to add flexibility to the grid and allow their utility to build solar in a place that might make a little bit more sense. So that smart pumping scenario, in my opinion, wins hands down. It's a marginal investment compared to all of the others, and it has this tremendous payoff and payback for the facility. So that was an example of EGI doing a very targeted project, getting really in depth, doing a lot of modeling. So we modeled the solar farm, we modeled the process, we collected their data and integrated that into a simulation of their actual process so that we could do this joint analysis. We also have a good track record at EGI of partnering on collaborative projects. So here is another project that my research group did. We did this artificial intelligence-based optimization for a coal-fired power plant. So this is similar in that it demonstrates the tremendous environmental and economic impact you can make just by operating your facility in a more intelligent way without requiring humongous capital investments. So this was a project that was funded by PacifiCorp, who's our power generation utility. This was a medium-sized project in terms of funding. We installed artificial intelligence-based optimization at a 480 megawatt unit. So that's one of these two units is 480 megawatts. Our objective for this particular project was to minimize their NOx emissions. So we teamed up with a third-party software developer. We helped them to make algorithmic improvements to their software. And the results of this are that we actually reduced NOx emissions by 18% with no capital equipment invested. This was just software. There were some minor investments into better sensors. So these are the results of our project, which ended a few years ago. So this is the percent range of capacity that the power plant is operating at. So 100% would be the plant is fully loaded. And then 25% is like the bottom end of that plant's turn down. That's as low as they can go. So we looked at NOx. So these are the NOx numbers. These are scaled because they don't want us to give away their actual absolute NOx numbers. But if you look, so before the project, we took some baseline measurements for NOx across their load range. And then each quarter, we made new measurements and determined that, so each quarter, we're making these pretty substantial improvements in their NOx. And going from pre-project to the last quarter of our project, we were able to reduce their emissions by 18%. Again, just a remarkable project, low cost, but you're using technology to have this major impact. We were able to spin that project off into a much bigger Department of Energy project. So one of the items that is facing these power plants is exactly what I was talking about earlier in this talk, is that because of renewables on the grid, things are getting much more variable. These coal power plants are doing remarkable things. They're actually being asked to be much more flexible than they were ever designed to be. So in 2016, this is sort of a baseline measurement. This is their generation, their load level. So here, plant is base loaded for most of the time. They rarely drop below about 70% load. So something changed between 2016 and 2019. And that is that this utility entered into the California energy imbalance market and are basically trying to provide California with this flexibility needed to help shore up their significant investments in renewables. So you can see how much more this plant is ramping. They're now ramping on a pretty much daily cycle, and it's now a very regular thing for them to go from the bottom of their load range at 25% all the way up to the top of their load range. And they're doing this just about daily. So our project uses artificial intelligence to help them address these issues. So this plant is having to ramp up and down, and they don't have the control and optimization tools needed to help them, to guide them through these transitions. So we partnered with PacifiCorp. We actually worked together to get nearly $4 million of funding for this project. So we became this partnership facilitator. We brought in many other partners. This is the basics of the technology that we're helping PacifiCorp and the third-party software vendor develop. So normally these plants are optimized based on what's called a steady state optimization or static optimization, where if this is your load in the red, you take measurements and you run your optimization algorithms, assuming that the plant is going to stay at this constant rate. It's going to stay at steady state. And so you optimize, and that works really well when your plant is fairly stable in operation. But when your plant is ramping up and down dramatically, like these plants are, what you'll see is that you optimize, like here you might optimize and you hold that optimal solution. But then by the next time you run your optimization, the plant has totally moved and the operational conditions are totally different. So what we are working on and what we have developed is what we call dynamic optimization. So this is still AI based, but now we build in process dynamics so that our models can not only predict how you're going to perform if you make these decisions now, but how you're going to perform by making a trajectory of decisions over the time horizon of your optimization. So our optimization scheme is much better able to follow these loads so that you might optimize here, but you build into it a knowledge that the plant is ramping down. And so you not only decide on your control moves for this instant, but for several instances into the future. So our goal here is to try and optimize at least a couple of hours in advance using dispatch signals from the operators here to know where this trajectory is going. So we are not only developing this, we call it dynamic neural network optimization. We are working with an advanced process control company called ADEX from Spain that does, they call it adaptive predictive control. So this Griffin tool basically sets the trajectory with an objective to maximize efficiency over that trajectory. ADEX basically says, okay, when Griffin gives us these set points, we are going to try and meet those set points in a fast but stable way. We are also working with another partner, Brigham Young University, who is installing this advanced sensor network. So they're putting new probes all throughout so that we can estimate the efficiency or the heat rate of the plant in real time. So EGI, on behalf of the University of Utah, turned this project into a tremendous coalition, working with PacifiCorp, with technology providers like Griffin and ADEX, and other universities like Chalmers University and BYU. So I'm getting near the end of my remarks. I just want to say, so the energy world is certainly changing very fast, but there's this tremendous opportunity for companies like yourselves or for researchers to really be the change, to be the ones driving how this whole transition is playing out. So I certainly don't agree with everything that the federal government does, but I do believe in being more sustainable while simultaneously trying to be friendly to businesses. So the ways that you can help be a part of this change are to start with getting an energy assessment. You could reach out to us and see what kind of services we can provide to you. Again, if you fit under the qualifications of the Industrial Assessment Centers program, we can do a lot of work for you at no cost because we're a federally funded program. If you wanted to get more in depth, or if you have specific projects that you're targeting, our team at EGI can come in and can help you analyze those projects, can work with vendors to try and get bids, and can do this this energy, economic, and emissions analysis for you to let you know how this project might actually impact your environmental performance as well as your economic performance. And then finally, there are a lot of federal funding opportunities out there. Right now, we can help partner, we can help lead grants or help you write grants that you lead. A lot of different arrangements here, and that usually comes down to the type of project. So I've got here on the right, this funding opportunity that we're currently working on at EGI. This is from the new industrial decarbonization. Sorry, it is called the Industrial Efficiency and Decarbonization Office at Department of Energy. It's new, so I haven't quite memorized the name. So they have a funding opportunity out there right now for a number of different topics geared at helping industry to decarbonize. I'm showing some of the example topics. So the first one is decarbonizing industrial heat. My research group is working on that. I have a PhD student who is analyzing how manufacturers can inject solar thermal into their processes so that you're using less fossil fuels, particularly natural gas, but still operating your system in a way that gives you the most economic impact and minimizes your environmental footprint while maintaining reliability. There's another topic for low carbon fuels utilization. And then the one I wanted to highlight here is this topic 3A, subtopic 3A, enabling flexible industrial energy use. So this is where we are really expert at EGI, is we can identify the flexible parts of your process. We can work with you to determine, okay, which parts of your process are absolutely mission critical. You don't want to do anything to disrupt their operations, and which parts of the process are a little bit more flexible, that you could use that flexibility to optimize your process in real time. So as you've hopefully gleaned from this presentation, I think that a major initiative toward decarbonization is just operating all of the systems that we've already got a little bit better. I think there's some real low-hanging fruit there. I don't pretend like this will be the solution to replace hydrogen storage or pumped hydro or battery storage. I think all of those things are going to be very important. But I also think before we get to investing billions or trillions of dollars into those technologies, I think we should take a hard look at what we're already doing and try to operate it smarter than we have been, because I think there's just substantial benefit there. All right, that brings me to the end of this talk. I've left plenty of time for questions, so I'm happy to have a good discussion here. Jennifer, I have not been monitoring the chat, so please let me know if anyone has asked questions in the chat. Otherwise, just feel free to raise your hand or speak up, and we're happy to answer those questions.
Yeah, I'm monitoring the chat, Kody. I don't see any yet, but yeah, you can raise your hand and I can turn on your video if anybody has a question, or just unmute you if you have anything you'd like to say. Oh, okay, there's Sudeep.
Hi, Sudeep. Good to see you.
Hi, good to see you, Kody. That was a wonderful presentation. Thank you for presenting and sharing those ideas. So I wanted to apprise you of a new funding opportunity that has come up from the Office of Clean Energy Demonstrations in DOE. And that's basically doing clean energy demonstration projects on a cost-shared basis in former or current mine lands. And I think
Okay.
Utah has a lot of scope for that. And this funding opportunity just came up last week. It was announced by the administration. And so I can give you the details, but I strongly think, I believe and think that, you know, EGI has a great chance if they were to sort of participate in this program by OSED, as we call it, the Office of Clean Energy Demonstrations. And they do a variety of things, like you can combine a variety of renewable resources like solar, geothermal, and use different optimization, proportions, and sort of do exactly the kind of thing that you're doing, or similar to what you're doing.
Would you mind sending a link?
I will put it in the chat right now and send it to you.
Thank you so much. That's wonderful.
Oh, yeah, and carry on the good work. Thank you.
All right. Thanks.
And
good to see you again.
Everyone. Good to see everyone.
Is DC treating you okay?
It's treating me well, rather well. Thank you.
Good. There's a lot going on there. We're glad to have people like you helping.
A lot. All right. I'll defer to the others for questions now. Bye.
Thank you.
Thanks.
All right. Well, any other last call for questions? And feel free, if you have questions that you want to pose offline, feel free to shoot me an email or connect with me on LinkedIn. I'm happy to answer any questions offline, or hopefully this has sparked some ideas of ways that you might want to work with EGI or go and target some of these big federal dollars that Sudeep mentioned. Oh, it does look like there's a question in the chat. Oh, that's just the link from Sudeep. Thanks, Sudeep.
I don't see any more hands up.
Okay, well, thank you everyone. I really appreciate you being here and being in attendance. I think EGI is just a tremendous organization and I'm happy to be a part of it. I really genuinely do think there's just so much potential to do some big, remarkable things right now. So if you have ideas that you want to chat with us about, please don't hesitate to reach out.
And this presentation is being recorded, so we can share the link later on LinkedIn, and you can share it with anyone you want to.
All right, well, thank you, everybody.
Yeah, thank you. Bye-bye.
Thank you, Jennifer.